Hello everyone, welcome to the Blue Team training series brought to you by Linode. This is an introductory guide to Blue Team operations. With that being said, let's get an introduction to Blue Team operations. Blue Team operations consists of the techniques and tools used by security analysts or a SOC team to proactively defend and protect against attacks by malicious actors. And that's really just very brief description as to what the Blue Team is responsible for. As I said, the Blue Team is essentially responsible for the security of an organization, but the way they go about securing an organization is threefold. So firstly, there's hardening of the digital infrastructure and the various assets. So, stuff like securing the servers, securing workstations, and then you have the proactive approach, which essentially involves, actively setting out or essentially identifying threats and, essentially testing the actual company or, performing adversary emulation and testing the ability of the Blue Team to actively, defend against these attacks. And as you can tell from the following slide, the primary objectives of the Blue Team are: number one, incident response, network traffic analysis, which is what we'll be exploring in this video, analyzing logs and event correlation, threat modeling and intelligence, identifying threat actors and their C2 infrastructure, identifying suspicious activity and indicators of compromise, and of course, digital forensics. Now, the objective of this training series is to provide you with the skills required to detect, harden, and protect the digital infrastructure and assets of a company from malicious threat actors. So now that you have an introduction as to what Blue Team operations are, we can now take a look at the Mitre Defend framework. So if you've gone through our Red Team series, you know that we used the Mitre attack framework to essentially give us an idea of various tactics, techniques, and procedures that attackers or APT groups utilize. Now, the Mitre Defend framework is essentially just like the Mitre attack framework, with the only difference being this framework is set up for defenders. So you can see it's broken up into the following sections. You have harden, detect, isolate, deceive, and evict. So we'll be essentially using this as a guideline, and as you can see under detect, this is where we're going to be starting off with network traffic analysis. The objective of this video is to essentially introduce network traffic analysis with Wireshark and showcase a few exercises as to how that will essentially help you understand how to detect malicious or suspicious network activity that has been captured in a PCAP file. With that being said, we can actually get started with the content pertinent to this video. So we're going to be taking a look at network traffic analysis with Wireshark. So the objective here is to analyze malicious network traffic with Wireshark and, of course, essentially identify important variables in regards to malicious network activity. So with the exercises that we'll be exploring, we'll essentially be trying to identify what system was compromised or what user was compromised, their IP address, the IP address of the C2 server being used by the attacker, and essentially just building or getting an idea of what happened, because that's going to be your job if you work in the Blue Team. All right, so what will we be covering in this video? So this is a high-level overview. We'll get an introduction to Wireshark. I'm going to be explaining PCAP files, and of course that will also be explained as we progress through the practical demonstration side of this video. We'll also take a look at how to install and configure Wireshark, how to customize the Wireshark layout, how to perform live traffic capture with Wireshark. We'll also be exploring capture and display filters, and we'll also be exploring taking a look at how to analyze malicious traffic in the form of PCAP files. So yeah, hopefully this is well-rounded. Now, one thing that I want to state before we actually get started is the fact that Wireshark is a very complicated or very, very useful tool that has a ton of functionality, and I'm essentially streamlining this video to cover the content that is useful from the perspective of a security analyst, or from the perspective of an individual who works in the Blue Team. So With that being said, we can actually get started by taking a look at some of the prerequisites for this particular video. So you should be familiar with Linux and the various command line utilities pertinent to Linux. You should also have a good understanding of Windows in regards to malware infections, etc. And just the various file formats. So you should have an understanding of what a portable executable is, a DLL, etc. If you're new to malware, especially Windows malware, be sure to check out our malware analysis bootcamp. You also need a good understanding of the OSI model and the layers that make up the model. As I said, this is going to be a very advanced, this is a very niche type of topic. So I'm going to assume that you're already familiar with the OSI model and the layers that make up the model. If you're not familiar with it, please take a look at our penetration testing bootcamp playlist on the YouTube channel. We have gone through and have covered, the OSI model as well as the TCP three-way handshake. So in addition to having an understanding of the OSI model, you also need to have a functional knowledge of TCP IP and UDP, as these are the most common protocols that you'll typically be working with or working around. You should also be familiar with a few information security concepts. So if this is your first time working in, or getting an idea as to what information security is, then I would recommend going back and taking a look at the pen testing bootcamp playlist. You also need to have a familiarity with HTTP and web technologies, because again, some of the traffic we'll be analyzing is going to be HTTP traffic. All right, so let's get started by getting an understanding of what Wireshark is. All right, so Wireshark is a free and open source network protocol and traffic analyzer that can be used to capture network traffic, troubleshoot networks, and much more. In essence, Wireshark allows you to capture traffic on a network and presents the captured traffic in the form of individual packets for granular analysis. Wireshark captures and dissects packets on a network and displays the various packet fields and headers based on the type of packet that was captured or the type of packet that you have clicked on or selected. All right, so simply put, Wireshark allows you to essentially capture traffic on a network. Now, the means through which you capture traffic on a network are going to depend on what type of access you have to a network. So in this video, we're not really going to be focusing on capturing live traffic, but we will be exploring that in order to explain a couple of things. Now, whenever you're capturing traffic, you're doing so through an interface, which is essentially the nomenclature that Wireshark uses to describe a network interface card. So when you're capturing traffic, you're going to be capturing traffic through your network interface card. So you could be using Ethernet or a wireless adapter or a Wi-Fi adapter for that matter. And based on your interface, this will essentially change or affect the type and the quantity of traffic you will capture. So if you're using a wireless adapter that doesn't support monitor mode, which allows you to capture traffic for other devices on a wireless network, then you'll not be able to capture that traffic. So if you are performing wireless traffic capturing or wireless traffic capture, you need a wireless adapter that can essentially be set to monitor mode. If you are on an Ethernet connection or a local area network, then you can pretty much capture all the traffic that's running through the network, which is again what we'll be using in this case. All right, so I spoke briefly about packets because that's what Wireshark captures. That's what it does. It captures packets. So what's a packet? Also known as an IP packet. That's what I'm referring to. So a packet is also known as a network frame. All right, it is a piece of data sent over a network, right? So what does a packet contain? Well, a packet contains data. However, what we're really going to be focused on in regards to a packet are the various headers and fields that are used to specify what type of packet it is, the source and destination IP address, as well as the protocol. So, you can think of a packet as sort of like a car, right? And, the car has a source where it came from. So your address and the destination is wherever you're going. So in order for a packet to be sent across a network, the two important pieces of information that are required are the source IP address and the destination IP address. And Wireshark allows you to view all of these headers for each individual packet, which is fantastic, right? So in the case of blue team operations, we're primarily interested in the actual flags to a certain extent. The source IP address, the destination IP address, the data contained within the packet, as well as the protocol. So, we want to know whether it's HTTP, whether it's a TCP packet, so on and so forth. So, again, as I said, if you don't have an understanding of networking, then again, this is going to be quite overwhelming. But hopefully, you'll get the idea as we progress. All right, so Wireshark for blue teams. In the context of blue team operations, Wireshark is typically used to analyze previously captured traffic that's stored in the form of a PCAP file for analysis and threat identification. What does this mean? As a threat analyst, if you will, if I can just use that very vague role as an example, you'll typically be given PCAP files to analyze. So, you'll be told, for example, if you're working for a company, there may be an infection, and as part of your job, you'll be provided with the actual traffic capture during that duration, and you'll be told to find out what happened. So, in companies that have a security infrastructure in place, traffic is constantly being captured and is being stored in a PCAP file. Now, I'll explain what a PCAP file is. And as a blue team specialist or operator, you will be required to use a tool like Wireshark to essentially analyze this traffic and identify what happened. So Wireshark can be used to identify when a packet was sent, the source and destination IP, and the type of protocol, in addition to the source port and destination port. Now, you might be asking yourself, why is this information important? Well, this information is very useful for security professionals, as it can be used to identify malicious activity by pinpointing the time the attack was performed or the time the attack took place, which is very important, as you can obviously imagine. The type of the attack. So in that regards, or in regards to the type of the attack, your job is essentially going to be review the data sent within a packet and try and form a chain of events in regards to what happened. So, for example, if the type of infection or the type of attack that affected a particular employee within a company was through a phishing email, your job is to try and identify what type of file was it that essentially facilitated the attack. Was it a spreadsheet that had a macro, so on and so forth? And of course, the IP addresses that were targeted or involved in the attack. So you'll typically be required to identify the system that was compromised and if applicable, the C2 servers of the C2 servers of the attackers, and essentially where the malware connects to. So this gives you and the actual blue team an idea of what happened, what malware was used, when the attack happened, and what systems were compromised, and what IP address or C2 server the malware communicates with. All right, so let's get an idea of some of the features that Wireshark offers. As I said, it offers quite a lot of features, and it's not just limited to the blue team. Network administrators, system administrators all use it for various reasons. One of the most important features is the live traffic packet capture, packet dissection, the ability to import and export captured traffic or objects, which we'll be exploring, a robust capture and display filters to essentially filter through and find exactly what you're looking for, the ability to search for individual packets based on various parameters, like the source IP address or the packet number, the ability to customize the color codes for packets based on your own requirements. We'll be exploring all of this during the practical demonstration. All right, so that's essentially what we're going to be working with in regards to the Wireshark features. Now, what are PCAP files? PCAP, which stands for Packet Capture, is an API that is used to capture and record network packets from layer 2 to 7 of the OSI model. Wireshark utilizes the PCAP file format to capture and store packets for later analysis. So whenever you're performing you're performing live packet capture with Wireshark, you have the ability to export or to save what you've captured into a PCAP file. You can then share that PCAP file with someone else and they can analyze what happened, which is fantastic, right? So network traffic captured with Wireshark can be exported or imported in the form of a PCAP file. This allows analysts to import and analyze network traffic that was captured on another network at a different time, which is really, really cool. So what you'll typically see happening is, let's say a company gets attacked, and nowadays we have crowdsourcing malware analysis and packet analysis. So what you can do is upload that PCAP capture onto a platform that offers that service, and you can have security analysts from all around the world import that into Wireshark, analyze it, and provide feedback in regards to what they think happened. So that's one of the really cool things with PCAP. You can essentially identify what happened on another network at a different time. All right, so in terms of installing Wireshark, Wireshark is a cross-platform, which means it's available for both Unix and Windows. When I say Unix, I mean Linux operating systems, Unix itself, BSD, in addition to Mac OS, and of course Windows. It's free and open source, so you can download it from the following URL, that is wireshark.org. All right, the lab environment. Now, the techniques demonstrated in this video have been performed on Ubuntu 20.04. So that's the system that I'm going to be using. Now, you can use whatever Linux distribution you're comfortable with. If you're using Kali Linux, that's perfectly fine. One thing to note is that, given the malicious nature of the traffic or the packets contained within the PCAP files we will be analyzing, we do not recommend following along with these techniques on Windows, as those PCAP files might be flagged as malware because they contain references to specific URLs and files, and Windows Defender or any other EDR or antivirus solution will essentially flag them as malware. So I would recommend following along with the techniques highlighted in this video within a Linux environment. As I said, feel free to use any Linux distribution you are comfortable with. Now, the PCAP files used in this demonstration are available under my own GitHub repository. The name of the repo is Wireshark Traffic Analysis. The link is attached to this slide. It is also going to be attached to the description section, so you can check them out for yourself. All right, so let's get started with the practical demonstration. I'm just going to switch over to my Ubuntu virtual machine, and we can begin by installing Wireshark, configuring it, and we can take a look at a few examples and essentially get an understanding of how to use it. We'll then be exploring or analyzing some malicious or some PCAP files with malicious traffic or packets. So I'll see you in a couple of seconds. All right, so I'm back within my Ubuntu virtual machine, and I'm currently on the Wireshark website. So I just wanted to highlight this before we actually get started. So on the website itself, you have the ability to download Wireshark, learn Wireshark. So I definitely recommend taking a look at the documentation if you're not familiar with something. In addition to that, Wireshark also has its own video series, which will explain, how to use Wireshark. But again, we are primarily focused on how to use Wireshark from the perspective of a blue team operator or a security analyst, if you will. All right, so you can click on download, and it'll give you various options based on your platform. So again, if you click on the latest stable release, there we are. You can see you have the Windows installer, the Windows portable app. You then have the macOS DMG images right over here. Now, if you're working on Linux, which I assume you are, then you can download or install Wireshark directly from your terminal, regardless of what package manager you're using. So on Ubuntu, Ubuntu is based on Debian, which means I can install it by through the use of the aptitude package manager. So I can say sudo apt get install and Wireshark, right? So that's the name of the package. So if you're on Arch Linux, you can say sudo pacman-s Wireshark. And if you're on CentOS or Fedora, you can use the yum package manager, and the package name itself is just Wireshark. Now, I already have Wireshark installed, but let's see if we have an update. We don't have an update, so I'm running the latest version of Wireshark. Now, I currently have Wireshark pinned to my actual dock here. And let me just show you what happens here. So I'm currently running as a standard user. So you can see right over here, I'm not root. This user is part of the sudo group. However, I just want to show you what happens when you essentially launch Wireshark through an unprivileged user, or if you launch Wireshark without sudo privileges. So I'll just open up Wireshark here, and it's going to take a couple of seconds. And there we are. So welcome to Wireshark. Now, on the greeting page or the welcome page of Wireshark, you'll immediately be provided with the capture filter bar right over here. That's the text field right over there. And you can see that it's going to display all your interfaces. Now, because we didn't start it with sudo or root privileges, we don't have the ability to capture packets. And that's because the ability to capture packets is limited to users with sudo privileges. So that means that we need to launch it with sudo or through the root account. So what I'm going to do is I'll open up my terminal here and I can say sudo Wireshark and I'll hit enter, and that's going to start Wireshark as root, which is perfectly fine. And now you can see it's going to list out all your network interfaces. Now, as I said, this is running through a virtual machine on a NAT network. And that means that the connection is essentially a virtualized Ethernet connection, and there are other systems on this network. And my interface name is ENP0S3. And of course, I can confirm that by opening up a new window here. And if I type in ifconfig, you can see that my default interface, and let me just bring that back here, is ENP0S3. My IP address, or the IP address of the Ubuntu virtual machine, is 10.10.10.31. All right, so that means that we can start capturing traffic from that interface. So let me just navigate in there, and I can immediately just click on it. And so if I click on it, you can see there's also a graph here that highlights the network activity. And if you hover over it, it'll tell you your IP address or the IP address associated with that interface. Now, before we get into display filters and capture filters, let's just click on the interface. All right, so if you double click on it, it's going to start capturing traffic. Now, as I said, this NAT network doesn't have, it really doesn't have that much going on in regards to traffic, but you can already tell that we've begun capturing, a few packets. Right, so this is essentially how Wireshark will display all the packets that have been captured, and the default user interface is going to be split into 3 panes. All right, so you have your packet list pane, which as the name suggests, will simply display a list of packets that have been captured. And the packet list pane has the following columns. Now, this, as I said, is the default configuration. We're going to be customizing this. So by default, you're going to have the packet number, the time, that's essentially when this packet was sent, the source IP address, so that's where this packet has been sent from, and the destination, that's where it's being sent to. The protocol is NBSS in this case, so that just tells you what protocol is the actual protocol for this particular packet. So if it's a TCP packet, it'll tell you there. If it's a TLS packet, it'll tell you that there, and of course ARP, so on and so forth. You should be familiar with the protocols. You then have the length, that essentially tells you the length of the data contained within a packet, and the information, which we'll get to. So these are the default columns here. And let's take a look at the top bar. But before we do that, let's take a look at some of the other panes. All right, so the second pane is the packet details pane. So this is, as the name suggests, will display the details for a packet that you have selected. So I currently selected the first packet that we captured. If I select another one, you can see that it essentially displays the details for that individual packet. This is known as packet dissection. So what Wireshark is doing for you here is it's providing you with the ability to select a packet that you'd like to analyze. And then within the actual packet details pane, you can essentially identify or view the various layers of the OSI model. So, you have your data link layer, and then of course you have your network layer, your transport layer, session layer, and then you have your application layer and then your presentation layer. So based on the type of packet you select, you're then going to be provided with details regarding that packet. So you can see this starts off from the frame. So, we have the data link layer, and then of course we have the network layer where we have IP. That's the actual protocol. So if it's UDP, that will also be highlighted there. So you can see you have UDP there as well. And that's because the protocol in this case is DHCP. If we click on the TCP packet, that is highlighted correctly there. So yeah, you have the ability to essentially go through all the layers of the OSI model, and you can then click on the individual. You can click on each of these layers and identify the data, or the various the various pieces of data associated with that layer. And really from our perspective, what we're interested in, or the two layers we're going to be interested in, is going to be the internet protocol, or this layer right over here. And then of course we are we're also going to be exploring the protocols. So just to summarize, from the top you have your data link layer, which again you typically associate with Ethernet. So this is where you have your frames. You then have your network layer, right, which is where you have IP, right, or ICMP. It could be IPsec or IGMP, right. You then have your transport layer, which is where you'd have protocols like TCP or UDP. So the transport layer is typically used for end-to-end connections. If there is a session layer, that will also be displayed. If there is a presentation layer for protocols like like SSH, FTP, etc., that'll also be displayed. And of course you have your application layer, which will display protocols like HTTP, SSH, DNS, and so this will make sense as we progress. And the final pane is right over here. This is the one at the bottom here. That's going to be your packet bytes pane, which essentially displays the actual data or content within a particular layer in ASCII, and you also have your it's essentially sorted by default as hex, right? So you can also display it as ASCII, or you can just show the text based on the packet by right clicking on it. You can also display it as a hex stream if you wanted to. And in this case, we'll just stay with the defaults. As I said, this might be a little bit confusing at this point, but it'll start making sense. All right, so that is essentially the interface here. Now let's take a look at the top bar. So we've already started the actual capture, and if this button is grayed out, that means that it's still capturing packets. So if you scroll all the way to the bottom, this is the latest packet that was captured, right? You have the ability to stop the live traffic capture or packet capture. So I can stop that there. And now you can see I have the ability to resume or to start a new packet capture again. Now I can also restart the current the current packet capture if I wanted to, and this little cogwheel right over here allows me to essentially specify the capture options, where I have the ability to specify the interface I would like to essentially capture with. And if you take a look at the actual column here, let me just resize that and reorganize it. You can see that we have the interface name, the link layer header, so that tells you the type of connection. If it's a wireless connection, it'll tell you that there, and promiscuous mode, right? So if this is checked, then that means you can essentially intercept or capture traffic that is being sent on the network for other devices, which is exactly what we were able to do when we ran the actual live packet capture. And if you're capturing on a wireless network, then monitor mode will be enabled if your network adapter supports it, right? And then it'll also tell you whether a capture filter has been applied right over here. And you also have the ability to enable promiscuous mode on all interfaces, right? So as it says, you probably want to enable this. Usually a network card will only capture the traffic sent to its own network address. If you want to capture all traffic that the network card can see, mark this option, and you can see the FAQ section for some more details regarding the actual promiscuous mode. You then have the output options where you can essentially capture to a PCAP file immediately, and the output format that you're provided with is PCAP next generation or PCAP, the standard PCAP format, which is what I recommend. In our case, we really don't want to be saving to a file unless unless we have identified some important information and we would like to export that traffic into a PCAP file. You then have the options here. Again, this essentially allows you to resolve MAC addresses, resolve network names, which I would recommend you enable. And you can also show the capture information during a live capture. I would recommend leaving that unchecked. You can leave all of the other options as they are. You also have the ability to stop, capture after, a specified number of packets, a specified number of files, when the actual capture reaches a specific size or at a fixed duration. So you can say after 10 seconds, I want you to stop the capture, which can be very, very useful. At the bottom, you have your capture filter, which allows you to essentially specify a filter. And based on that filter, that's the only traffic that will be captured. Now, as I said, this is something that I will be walking you through in a couple of seconds, but it's something that you want to avoid whenever you're capturing traffic, because ideally you want to capture all the traffic or all the packets that are being sent on a network and not limit this unless you want to do so. Right? That's where display filters will come into play. Display filters essentially allow you to filter through the current capture, which again, you're going to be capturing all the traffic. So you can use a display filter to filter through those packets as opposed to filtering or essentially using a capture filter, which will restrict what is being captured based on the filter you specify. All right, so that's the actual cogwheel there. That's capture options. You then have the ability to open a capture file or a PCAP file. You can save this capture file as a PCAP. So, for example, I can save it on my desktop and I can specify the format as Wireshark or TCP dump PCAP, specify a name, save it, so on and so forth. I can then close this capture file. So I can say continue without saving, or I have the ability to save it. If I hit enter, you can see that is displayed. I can also reload this file, if I'd made any changes and, if I wanted to go back, I can also find a packet, go to the previous packet or the next packet. I can go to a specified packet, and I can also go to the first packet that was captured and, of course, the last packet. You then have the ability to automatically scroll to the last packet during a live capture, which is very useful. And then, of course, this is where the actual coloring rules will come into play, which I'll get to in a second. And of course, one of the most important features is the ability to enlarge the main window text here, as you can see there. And you then have the actual ability to zoom out, right? So what we're going to do here is let's just stop this capture, and I'm just going to go into options, and I'm going to disable the resolve network names option there. And I'll start that again, and that should provide us with the source and destination IP, because before that it was essentially providing us with the host name, which is not bad, but in our case we really don't need it. All right, so now that we have an idea as to the default interface, let's take a look at how to customize this interface. So I'm just going to stop capturing packets. There we are, that's perfectly fine. And let's take a look at how we can customize a couple of aspects in regards to the user interface and the way the actual panes are displayed. And we'll also be exploring the coloring rules for packets, which again is something that we'll constantly be taking a look at as we progress. All right, so what I'm going to do is I'm going to start another live packet capture on ENP0S3. That's my default interface. In your case, the name will probably be different. It could be Ethernet 0, Ethernet 1. You get the idea. So I'll double click on that. And let's head over into Edit and into Preferences, right? So this allows you to customize Wireshark, and we are primarily interested in the appearance section at this point in time. So under columns, this is where you can add, you can add to the current columns here under the packet details or the packet list pane, which I'll get to in a second. You then have your font and colors, which again, you can change based on your screen resolution and aspect ratio. And I'll get into how to zoom in a couple of seconds. And you can, of course, change the font and the font size. So for example, I can make that 11 and I can hit OK, and that increases the actual size there. However, I do not want that to be italic or italicized. So I'll just say I want this regular, and I can hit OK, and there we are. Fantastic. So you can see that that increased the size. Now you can also zoom in and out based on your own preference, which again is very helpful. Another useful keyboard shortcut is the Control, Shift, and Plus key, which will zoom in. So I can zoom in like so, and I can also zoom out by using the Control and minus key combination. So that looks like it is appropriate. So I'll just zoom in. There we are. Hopefully that's visible to you now. And if we go back, I'm just going to stop the packet capture. If I go back into Edit and Preferences, and I click on Layout, you can see that it essentially provides you with various layouts based on your requirements. So based on your screen resolution and the aspect ratio of your monitor, you can essentially sort or essentially modify the way or the layout of your panes. So you can see that, on pane 1, you can specify whether you want a, you can essentially specify what pane you want displayed on pane 1, pane 2, and pane 3. So let me just restore the default. So you can see on pane 1, that is the packet list. That's the packet list pane. On pane 2, we have packet details. On pane 3, we have the packet bytes, or rather the actual packet bytes pane. Now, as for the layout, I can say I want pane 1 to be displayed on top, and I want pane 2 and 3 to be split at the bottom. So if I hit OK, you can now see that that actually just reconfigures the layout here of your panes. And as I said, based on your screen resolution and aspect ratio and your own personal preference, this might work for you. And in my case, I typically like using this in addition to a couple of other ones. So you can play around with this based on your own preference. You can also have 1 and 2 displayed side by side. I don't recommend doing that. The objective really is to have the packet list pane essentially have its own wide layout, or to have that display information without any restriction, because a lot of data is being displayed there. That is very important during analysis. So I typically use this option or this layout here, or layout 2. Right, and as I said, you have the ability to customize what is displayed in pane 1, pane 2, and pane 3. You can also show the packet separator if you want. That is going to add a little line here that again is really cool for visibility. If you are visually impaired in any way. And so I'll just go into preferences there, and I think we can leave that on. I really like that. And of course, you can also show the actual packet number within the status bar, but we're just going to leave that as is. Now, the next aspect of appearance that you can customize is the columns. Now, this is going to be very important for the exercises we'll be exploring. So you can see that it starts off with column 1 all the way to the bottom, which displays information. We want to add a couple of columns to this. You can see we have the time. We also have the source and destination address, the protocol, the length, etc. The first customization we want to change is the actual time. So you can double click on that there. This is going to bring a drop down. So we want to have this displayed in UTC time. So that will provide you with an accurate idea as to what time that packet was sent, because right now it just sends the actual time based on the information it obtained from the packet. We want to add another column for the source port. So that's the new column there. You can click on the title, on the actual title there to change it. So we'll say source port, and we can then click on the type here, and we can then say we're looking for the source port, and that is going to be the unresolved option there. So SRC port, and we can then add the other column, which is going to be the destination port. So I'm going to say destination port, and of course you can use whatever heading you want or whatever title you want. And for the type, we are looking for the destination port. So destination port right over here, unresolved. And we can then select and drag and drop it in regards to where we want it. So I'm just going to have this below the source address. So let me just drag it there. Hopefully it allows me to add it. There we are. So source IP address and source port, and then destination. The destination port can fall under the destination IP address right over here. Fantastic. So we can hit OK, and now you can see we have a few more columns added there. And what you can also do, which is really very helpful, is you can resize this based on your own requirements. You can see that the time is now being displayed in UTC format, and we can resize things. We can resize these columns based on our requirements. One thing I would recommend doing is aligning the actual source and destination ports so that it displays the information in a much more readable format. So you can see that starts to make sense. And you can also do this for the IP addresses so that you can make sure you can read it. I'm just going to get rid of that for the source and destination IP. I only like centering the source and destination port option. And yeah, so this information, as I said, is going to be very, very useful. So you can then resize, this so that everything fits within your screen. And again, you can always zoom out if you want to. So there we are. That's how to add custom columns. Now let's talk a little bit about color coding specific types of packets. All right, so if I go into edit, or rather into view, and I click on the actual coloring rules, the coloring rules menu item here, you can see that the colorize packet list option has been enabled. If I disable it, which I can also do directly from here, you can see that it gets rid of the color coding for the packets. Now, this is something that I don't recommend that you do, primarily because color coding is very important. And Wireshark has its own color coding based on the type of packet. So if I go into view and the color rules, you can see that for specific types of packets like ARP, or for specific protocols like TCP, UDP, ARP, SMB, HTTP, it has its own color codes. And the filter here this is the actual display filter. So for example, if an ARP packet is captured, then it'll be color coded as this light orange or creamish color. If it's a TCP or UDP port, you're going to have this light magenta or purple color here. And for UDP, it's blue. For SMB, it's going to be yellow. For HTTP, it's green. So I recommend going through these color codes so you understand what's going on. I'll be showing you how to add your own color code and why that is useful in a couple of seconds. All right, so now that we've got an idea as to how to customize the actual panes and how to essentially modify the font, how to add columns, let's get started with display and capture filters. All right, so let's get started with a few capture filters, right? So I'm just going to get rid of this capture file there, continue without saving. And we can specify a capture filter, within the actual capture filter toolbar here. So what I can do is, I can give you a few examples. Now, capture filters and display filters are very different. We're not going to be focusing too much time on capture filters because, as I said, that's not something that you should be doing. But this is fairly simple. You have the ability to filter by protocol. So, I can say TCP. That means that only TCP traffic or packets will be captured. I can also say, UDP, and essentially specify all the protocols that I would like to filter. So I can also say ICMP. So, if I type in ICMP and I say, I click on my actual interface there, you can see that that is only going to capture ICMP traffic. So if I say, for example, if I head over into my browser and I perform an HTTP request, so I'm just going to resend that there, and I take a look at Wireshark, you can see nothing is captured. If I, however, perform a ping, so I'm just going to say ping google.com, that's going to send, essentially send an ICMP packet, right? Because that's how pinging works. And you can see in this case, only ICMP packets are being captured. However, the problem with this is not all traffic is being captured, which is what we want. So let's go back into the actual capture filter section. So as I said, you can filter through protocols. You can also specify, whether you want to limit the actual packet capture to specific IPs. So for example, I can say source, and I can then specify the IP that I would like to filter, right? So if I only wanted to capture traffic that was being sent by a particular IP, maybe an IP like 10.10.10, let's see, 31, that's our IP address or my IP address, I can say that. So source is 10.10.10.31. I can then hit enter. And again, I'll just make another HTTP request here. And if we go back into Wireshark, you can see that it's only going to log traffic, that has been sent from this IP address. That's fairly simple to understand. And of course, we can again modify that and say, we can also change that to destination address. So I can say if the destination address is 10.10.10.1, which is the default gateway on this NAT network, I can hit enter. And now this is only going to display packets with the destination header or field set to the IP address that we specified. So again, that is fairly simple to understand. So I can perform a quick ARP scan using the netdiscover tool. So I can say I can say sudo netdiscover, and that would essentially connect to that particular IP, or I can just ping it. So I can say ping 10.10.10.1. And you can see we get a response. And if we take a look at Wireshark, you can see it's only displaying it's only displaying packets, where the destination is the IP that we specified, irregardless of the protocol. Now, one of the really cool features of both the capture and display filters is the ability to chain or to use logical operators to essentially, make your filters much more robust in regards to the information you're looking for. So if I just, get rid of that there, I can combine filters with each other based on what I'm looking for. So if you're familiar with logical operators, if you've performed programming, I can use the AND operator, right? I can say AND, I can say OR, I can also say not if I wanted to. And, based on the type, whether you're using a capture filter or display filter, this will change. So what I can say is I can say the source is going to be, let's say this is going to be our IP address or my IP address. And then I can say, and I only want to display ICMP packets. So what's going to happen here is Wireshark is going to capture packets where the source IP address is set to our Ubuntu IP, and the type of the packet or the protocol is going to be ICMP. So again, we'll just start the capture there. If I perform a request here, an HTTP request, and I go back into Wireshark, you can see nothing captured there. However, if I perform a ping on something like google.com, and I'll just give that a couple of seconds, there we are, and I can go back here. You can now see it's only capturing those packets irregardless of the destination. So you can see that that only captures packets where the source IP is the one we specified, and the destination, or rather the actual protocol, is ICMP. Now let's explore a few other options. So I'm just going to get rid of this here, and that's the ability to specify the port, right? Now the port can be specified in the form of, if we just click on this here, I can say, for example, port, we can just say 80, right? So that's only going to limit it to port 80. However, in order to specify this, you would essentially need to say, so, we can essentially say source is going to be, we can just specify the Ubuntu IP there, and we can say 80, but of course that's not specified. So we can essentially say, as an example, so we can say TCP and 80, or we can say and we can just filter through that. So, we can limit the type of packet that we're capturing in regards to the protocol. So, I can say, for example, HTTP, and I would need to add a logical operator. So, and HTTP, or, we can customize the filters, based on a variety of parameters. So as an example, I can say, instead of saying HTTP, I can say the source IP is the following, and I only want you to display packets where the source IP is what we've outlined there, and the destination or the actual port is port 80, right? So that means any packet where the port is set to 80 and the source IP is set to our Ubuntu IP address, we can say that as well. And this is not just limited to our IP. We can also specify any other IP within the actual subnet, and that will work out just fine. So I can start that now. So I'm just going to click on the interface there. If I make a request, that should be captured within Wireshark based on the capture filter. There we are. So that is essentially how to use your capture filter. As I said, I don't want to spend too much time on capture filters. So let's get rid of this here, and let's talk about display filters. So I'll just get rid of the capture filter there. Make sure that that is always empty, because if there is any capture filter, then it could potentially mess up, in terms of limiting what types of packets you can capture. So I'll click on my interface there, and I'm just going to give this a couple of seconds to capture a wide variety of packets. So HTTP packets. We can also throw in a couple of ICMP packets. So I'll just perform a ping on google.com. And yeah, so we should be capturing quite a lot of traffic. So you can see this is capturing, packets, from multiple IP addresses, from the Kali Linux IP, from other systems as well. So for example, the actual IP address of the web server or the vulnerable virtual machine that we're going to be using for a couple of demonstrations, so on and so forth. And we can just stop that capture there. So your display filter is right at the top. Now, as I said, the display filter logical operators are going to be different based on the fact that you're now dealing with the display filter. So let's take a look at a couple of examples here, right? So if I wanted to filter HTTP requests, I could say HTTP request. There we are. And if I hit enter, that's going to filter and provide me with only the packets that are essentially HTTP requests, as it does right over here. So you can see we requested the following website, that is Motilidae index.php, and the web server is the following IP here on port 80. The protocol is HTTP, right? I could also just limit it to only HTTP packets. So if I hit enter, that's going to display the entire range of HTTP packets. I can also filter by either TCP or UDP, and based on what you specify, you'll be able to filter through what you're looking for. So I could also say DNS. I can also say FTP, and you can see we didn't capture any FTP packets, SSH, so on and so forth. Really, any protocol that you want to use or that you want to filter with, you can. All right, so what if I wanted to specify a source and destination IP address and sort of use the logical operators to fine-tune my actual display filter? So for example, I'll just hit enter to take me back to all the packets here. I could say, for example, the IP.source, so that's the source IP, is going to be equal to, so we use the logical operator double equal sign, that means equal to, and then we can say the source is 10, 10, 10, 31, and then instead of saying and, we use the double ampersand symbols right over there, and we can then say the IP.dst is going to be equal to the IP address of the actual web server. So in this case, it's 10, 10, 10, 33. And we can also say and, this is one of the great things, we can say and TCP dot, we could say TCP dot port is equal to port 80, right? So you can now start to see the power of Wireshark. So if I hit enter, that's going to limit the actual packets to essentially meet the actual filter that we specified. So it's only displaying packets where the source IP is our Ubuntu VM, the destination is the web server, and the port is port 80. Now, if we get rid or we say another port, maybe like 21, you can see it didn't capture any traffic there. All right, so that's just one example. Let's take a look at a couple of other important capture filters. Now, another important piece of information that you typically be looking for, within a local network is DHCP data. So I can do that by saying DHCP, hit enter. There aren't any DHCP packets. So, if I was to perform an ARP scan or a network discovery scan, for example, with Nmap or NetDiscover, if I type in NetDiscover, you can see that doesn't exist. So I'm just going to install that utility here. So sudo apt-get install NetDiscover, and I'm just going to install that there. So I'll give that a couple of seconds. NetDiscover is a utility that allows you to discover other IP addresses or hosts on a local network by sending ARP requests, and based on the responses, you're able to tell whether that device is online or offline or is on the network or not. So I can say sudo netdiscover, because this is also, essentially sending packets or ARP requests. ARP stands for the Address Resolution Protocol. ARP is essentially used to resolve IP addresses to MAC addresses. So, I could say sudo netdiscover I, and then I would need to get my interface here. So what I'm going to do is let me just split another terminal. So I'll say ifconfig, and the name of my interface is enp0s3. So enp0s3, and the network range or the subnet is 10.10.10.1.24. Hit enter, and that will start capturing ARP traffic. Now, before we do that, I'm going to start another capture here. So we'll get rid of that filter and we'll start another capture. Remember, we don't have any capture filter. We're going to be using display filters. So I'll just run the command again, and you should start seeing ARP requests here. There we are. We can actually see it there. So we have an ARP request, and if we take a look at the actual packet details pane here, if we click on the ARP protocol, that tells us the actual type of request. So we have a request here. Do we have a response? Let's see, that's a reply. So there we are, we have the response. So ARP is essentially saying, or what ARP is used to say is it's essentially saying, okay, who has this IP address? Can you please tell this IP? And then we get a response. So you can see we get a reply. And yeah, so it's fairly simple to understand. So yeah, that's just one example. As I said, there are a couple of other important search filters, or rather display filters, we can use in order to discover important information that is typically important. So another important piece of info is information like NetBIOS. So for example, if we're working on an environment that has Windows systems, you can essentially identify Windows systems on that network, or packets that were sent or received by a Windows system, by saying NBNS. So I can say NBNS. We don't have any NBNS packets here. That's also quite useful. We have a couple of other examples that we can use. So, we can essentially use the HTTP filter, which is going to be quite important. So we can say HTTP request or response. We can also limit it. We can also identify or use the HTTP.cookie display filter. If we hit enter, nothing there. So we could say HTTP.cookie, and there's multiple ways of using the actual display filters. So let's take a look at a couple of other filters. So I've already mentioned the IP source and destination. You can also limit, what is displayed based on the IP address. So this will display all packets that have an IP address, regardless of whether it's the source or destination IP. And you can specify the value there. So I can say 10.10.10.33, hit enter. That's going to display, all the packets that have that IP. So you can see in this case, the first packet has that in the source, and the second one has it in the destination. So you can also filter based on a particular IP. You can also filter by IP ranges. That can be done by saying IP.address, and this is where the logical operators come into play. So I can say greater than or equal to 10.10.10.1. So that's the first IP within the subnet. And then I can use the logical operator. So I can say and or the double ampersand. And I can say IP.address, and this is where we specify the end of the range, is less than or equal to, we can say 10.10.10.33. So we're essentially saying only display packets within this IP range. So the IP range is 10.10.10.1, and the actual end of the range is 10.10.10.33. I can hit enter, and as you can see, that's only going to display IPs, within that range. And of course, you can also customize this to be the source and destination based on your own requirements. And of course, you can also chain this with multiple other filters. So I can essentially say TCP.port, and you can also customize the destination port. So I can say destination port is let's say we can set that to 80, and that's only going to display the packets that that essentially meet those parameters. So again, it's fairly simple to understand, and you'll be in situations where you'll need to be able to chain multiple filters based on what you're looking for. So an example of this would be, I'm just going to stop that there, and I'm gonna just run another capture here, and I'm just gonna I'm just gonna reload this web page. That's an HTTP request. So an example of this would be when you're working or you're trying to analyze what happened on a network and you're trying to identify infections via a malicious document, for example, that came through a particular website or an attachment. I could say the IP address. I could say IP address is equal to 10.10.10, let's see, 31. And I can then say and http.request. There we are. And I can just hit enter, right? So I can then limit what I'm looking for based on the source IP, or rather, the IP address itself. And I can then view, for example, the various HTTP requests. And there's multiple ways I can filter. So for example, I can say HTTP request, and then I can also say that is equal to, let's see if I can do this here. So no, I need to say HTTP request.method is equal to, for example, if this was a post request where I was sending data, I could hit enter, and that limits it to a post request. There's also a couple of other ones that are quite important, like the HTTP host filter. So I can say host, and that will essentially limit it to HTTP hosts, the various HTTP hosts. And I can then specify a host name. So if there is a relevant host name, I can specify that as well. In this case, I know that there isn't. You also have the ability to filter based on Ethernet, right? So if you're working within the data link layer, I can also say ethernet.address, and then I can specify the MAC address that I'm looking for. So, I could say, for example, ethernet.destination or .address, and obtain my MAC address. So if I just open up a new tab here, I can get the MAC address for my interface. Let's see where I can find that there. That should be displayed. There we are, Ethernet. So I'll copy that there. And I can say IP Ethernet address equal to the following. So I can paste that in there. And as I said, you can filter. You can essentially use filters to display packets based on various layers of the OSI model, not just limited to the network layer or the transport layer or the application or presentation layer. So there's multiple, filters that you can utilize. As I said, we'll be taking a look at them and a few other interesting ones as we explore the exercises. All right, so what I want to explore now is protocol filtering, right? So I'm just going to stop that capture, and we're going to take a look at a few examples, right? So I'll just begin the capture in a couple of seconds, but what we're going to be doing is we're going to be making a few requests or interacting with the target system through various protocols. So we'll take a look at DNS, FTP, Telnet, HTTP, HTTPS as well. That's perfectly fine, and SSH. So the objective is to try and view traffic based on a particular protocol, and we'll also be taking a look at streams, right, and how streams can be used. So as I've already explained, I'm just going to start the capture there. We've already explored DNS, right? So I can just clear that out there, and I can say ping, or we can say ping google.com to view the actual DNS request and response. So when we're saying ping, what our system will do initially is it will essentially reach out to your primary DNS server, and it'll say, okay, can you please tell me the IP address of google.com so that I can make a request, regardless of whether it's an HTTP request or an ICMP request. So if we take a look at Wireshark, you can see we have DNS at the top here, and of course we can filter by protocol, so we can say DNS. So you can see this is the standard query where we're essentially saying, okay, so who has, if we take a look at the queries here, we're essentially saying, could you please provide us with the type A DNS record for google.com, which means could you please provide us with the IPv4 address for google.com. We then get the actual query response. This is also the request for the IPv6 address. As you can see, type is specified there. We then get the response for IPv4, whereby it tells us, okay, the IP for google.com, and then it provides us with the IP address, right, for google.com, so that we can actually connect to that server. So you can see the answer here is google.com. The type A DNS record is the following. So that's essentially telling my computer what IP address to connect to, because computers don't know what google.com is. They only know IP addresses. And it does the same for the IPv6 IP address. So again, if you ever want to filter via DNS, you can do that as well. You can also filter via DNS records. So I can say DNS A, and if I hit enter, you can see it's only going to display the response where the A address or the A DNS record, which means the IPv4 address, is displayed. And you can see we have another example here whereby the browser has made a request to the following address, that is contal.services.mozilla.com, and it provides us with the IP address for that particular domain. So, DNS is fairly simple to understand. All right, the next protocol that we're going to be exploring is FTP. Now, as I said, there is a vulnerable Linux server that's running within this particular subnet or within the NAT network that has the IP address 10.10.10.33, and it has various services running on it. So it has an FTP server. It also has Telnet, a web server, as we've already been able to tell, and it also has SSH running. So what we can do is let's perform, or let's try and authenticate with the target via FTP. So I'm going to say FTP and then specify the actual target IP address, and then the port in this case is port 21. So I can just provide the credentials MSF admin and MSF admin. And hopefully I typed in the password correctly. So I'm just going to exit and try that again. So MSF admin and MSF admin again, and there we are. So authentication was successful. So I can say dir to list out the contents of this directory, and if I head back into Wireshark, I can then limit it. I can then filter the packets based on the protocol FTP, and you can see that we can actually because we're capturing all the traffic, we can actually intercept the packets being sent, and you can see that there was a response here. And we have the actual username specification or the authentication where the username was specified as MSF admin. And because FTP in this context is not encrypted, the passwords can be identified. So that was the incorrect password that I specified, as you can see there, login incorrect. And it then tells us to re-authenticate, and we specify the correct password, and there we are. So why is this important? Well, this is very important because you could potentially identify brute force attacks or incorrect attempts whereby an attacker was trying to gain access, so on and so forth, right? So that's FTP. Again, if you take a look at the other packets that were captured when we typed in dir, so there we are, here comes directory listing. We actually typed in dir to get a directory listing of the current working directory, and you can see that we actually get a response there as well. Now, one of the great things is if we right click on a particular packet, we can follow the TCP stream to essentially put everything together, because streams are very helpful to essentially see how a protocol communicates in the way that the application layer sees it. So, the application layer essentially uses streams whereby, you have multiple packets with multiple pieces of data in the form of streams. And, from our perspective, it can be really hard to tell what's going on. And you'll actually see this when we'll be working with Telnet. But if I say follow the FTP stream, it essentially tells me what happened in a way that makes sense to me. So you can see the actual service banner for the version of the FTP server running on the target. I then authenticated using the username MSF admin. And in this case, I provided the wrong password and it told us login incorrect. I then logged in again, so on and so forth. But this is only pertinent to this request or this authentication attempt, right? Now, if I clicked on the other FTP, so for example, I click on this one here and I say follow TCP stream, it now provides me, that's still the incorrect one. Let's see if I can identify the other login here. So where did I specify the correct password? That was the username there. And then I believe that I was able to authenticate. It's still showing the display filter there. So if I click on, if I head over here and we click on the actual packet pertinent to the actual, there we are. So that's the one there. So we can click on follow TCP stream. You can see now it provides me with the stream pertinent to the successful authentication with FTP. Right, so streams are very important. So let's take a look at Telnet. Now, as you know, Telnet is unencrypted, which means if we authenticate, we should be able to see the actual password in clear text. All right, so I'll get rid of that display filter there, and I'll just exit from FTP here, and I'll say Telnet, we can essentially specify the target IP there. So 10.10.10.33, hit enter, and I'll say MSF admin and MSF admin for the password, and we're logged in. LS, there we are. So let's filter. I'm just going to stop the capture there, and let's filter for FTP, rather for Telnet. So I can either say Telnet, or I can say TCP.port based on the protocol is equal to 23, which is the default Telnet port, and I can hit enter, and we have the same thing going on here. So we can click on the first packet sent. So I can say follow the TCP stream. All right, so you can see that this displays the entire authentication, essentially whatever we did, or this essentially joins every packet together, every Telnet packet, and it displays it in a way that makes sense to us, right? But in the backend, it sends it in individual packets or in individual streams. So I'll give you an example of this. Let me see if I can identify where the authentication was actually, begun, right? So if I click on Telnet data here, and we have the data there, let's see what is displayed there. So there we can see the individual fields. So if you went by it by a packet by packet basis, you can see in this packet the M was sent. In the next one, the S was sent. So MSF ADMIN. So that's why the actual stream for a particular packet is very important. So, based on the protocol, so it could be a TCP stream, UDP, TLS, FTP, etc. In this case, it's TCP. You can now see it essentially gives me the entire stream, or essentially, it essentially allows us to see what was going on, right? So in this case, we can see this was the Telnet banner. It asks us for the username, and you can see in this case it's not being displayed clearly, and we have the ability to filter or to change how the data is displayed to us. We can either display it in UTF-8 format as raw, so this is raw data. We can also display it in ASCII format, which is readable, in C arrays if you want to as well, so hex as well. So that's fantastic there, and you can see the actual offsets there for MSF admin, etc. So Wireshark is really awesome. So you can view the entire conversation, or limit it to a particular set of communication based on the IPs there. I can also search for example, username. I can say username. Is anything displayed there? Can I filter by password? There we are. So really cool. So that's Telnet. That's fantastic. Now let's talk a little bit about exporting this capture, this packet capture into a PCAP file. So if I wanted to do that, I can click on this icon here. I can say save this packet capture, computer. I can save this under home, Alexis on my desktop, and I can give it a name. So I can say Telnet, Telnet PCAP, and I'll select the format as PCAP and save. And I can now minimize that, and I'll head into my desktop here, and you can see we have the PCAP file. So I can now share this with anyone in the world, and if they have Wireshark installed, they can open it up with Wireshark. So there we are, it opens up with Wireshark, and I can now navigate through the actual packet capture within that PCAP file. So really cool stuff there. All right, so that is how to export packet capture into a PCAP file. Now that we've taken a look at that, we can also explore SSH traffic if you're interested in that, because that is quite important. So what we'll do is we will get rid of that there, and we can then start a new capture there, and I'll just exit from the actual FTP connection there. And I can authenticate by saying SSH MSF admin at the actual IP, so 10.10.10.33. Hit enter. I'm going to accept, and I'm going to just provide the password. And remember, one of the reasons why SSH was the successor to Telnet was the fact that it encrypted communication. So in this case, we shouldn't be able to see the actual password. So I'll just switch over here, and it looks like, yeah, the packets are being captured, and we can just stop the capture there. And I can say SSH, there we are. And now you can see where we have the encrypted packets. That's where the actual passwords and communication was being sent. And in this case, unless we have the actual, the actual SSH key pair, we cannot decrypt this. If we did, then we would be able to actually decrypt these particular packets. So that is SSH traffic. Again, you can filter or use any display filter you want to use. Now, let's talk about HTTP traffic, and then we'll move on to our exercise, which will be to decrypt HTTPS traffic and take a look at an infection. So what I'll do here is I'm going to get rid of this capture there, and I'm going to begin a capture, and I'll head over into the actual web application that is hosted on the web server or the vulnerable server. You can see that's the IP there. This is a vulnerable web application called Mutilidae. And because this website or web app doesn't have an SSL certificate, it means that communication between the client, which is my browser, and the server is unencrypted. So if a user was to log in with credentials like maybe admin, and I hit log in, regardless of whether those credentials are correct, that should actually be captured by Wireshark. So if I hit enter, you can see that we have quite a lot of data that was captured, right? And let's take a look at how to use the actual packet coloring here to, how that can be useful from a security analyst perspective. So I'm just going to stop that there. And what we'll do is let's open up view and the coloring rules. And let's say I only want to display HTTP post requests, right? So, and I want to give that its own unique color, so that whenever I capture traffic again, or whenever I import a PCAP file, and based on my own personal requirements, I can identify those packets based on their color. So I'll create a new coloring rule, and I'll call this we'll call this HTTP post, right? And the filter in this case is going to be we will say http.request, and we're going to say request method is going to be equal to post, right? So we're only looking for post requests, and post requests typically mean that we're interacting with a login form, etc. And now for the color, we want to change the background color to something. Let's use something that's easily identifiable, maybe this very bright pink there. And I can then enable it by checking the actual checkbox. Then if I hit OK now, you can now see that the actual coloring allows me to easily identify a particular type of packet that might be interesting to me, right? So if I right click on this packet and I say follow TCP stream, you can see that in this case, it essentially shows me the entire post request. And because the connection is unencrypted, we have the username and password there for the web application, which again gives us the HTTP status code 200 OK, which means authentication was successful. This information can also be obtained from the actual packet details pane. So if we take a look, let me make sure I'm clicked on it there. We have the HTML form there. And you can see the username field for that form is specified, or rather the information that was sent is specified. Now, as I said, this will work regardless of whether or not it's our IP address. It can be any IP on the network. And if they're authenticating to an unsecured website, then, this is going to be a problem. But yeah, all I wanted to showcase is how you can utilize filters and, essentially filter through protocols and find what you're looking for based on your requirements. So I'll just go into the coloring rules there, and I'll get rid of that coloring rule because, again, I don't need it. So there we are. Okay, fantastic. So now that that is done, we can take a look at an exercise here. We will be required to analyze malicious traffic, and the PCAP file will contain HTTPS data, or HTTP data that's been secured with a TLS certificate. and will be required to decrypt it and essentially identify the type of malware that was used to infect one of the systems on the network. So this exercise file is again part of the GitHub repository that I highlighted within these slides, and I'll just navigate to the GitHub repository now. So I'm currently on the GitHub repository, and this is the zip file that you want to download. It's called Wireshark Tutorial on Decrypting HTTPS, SSL or TLS traffic. It's a zip file. The password for the zip file is infected. I've already downloaded this on my desktop, so I'll just navigate there, desktop, and you can see we have it here. So I'm going to extract it. I'll just say I'll use the archive manager, extract to my current working directory, and the password is infected. And I'll hit enter. Extraction is done, and you'll be provided with the actual Wireshark tutorial keys. This is the SSL encryption keys in order to decrypt the SSL traffic. These keys were captured during a man-in-the-middle attack that was performed when this traffic was being captured. And this is the actual PCAP file. So we can open it up with Wireshark. You do not require Wireshark. You do not require, you're not required to run Wireshark with sudo privileges to analyze PCAP files. That's only relevant when you're capturing packets. So I'll open it up with Wireshark here. And yeah, so this is the data there. Now, because we're running this through our current user profile, we are going to head over into preferences, and we're just going to add those columns that we added to the root, to the actual root user profile. So that's going to be the source and destination, the source and destination port. So I'm just going to do that right now. All right, so I've added the columns and set out the layout to display the panes as follows, as we did previously. And you can see that what I'm going to do here is I'm just going to align this, the source and destination columns. I'm just going to align them in the center there, and we can see what's going on. I'm just going to zoom in a little bit here. So I'll just zoom in so we can actually see what's going on. All right, so the objective here is to decrypt, essentially decrypt communication between a particular system on this network. As I said, I don't know anything about this network. You can see it's on a different subnet. This was what I was actually talking to you about. So as an individual who works in a blue team, this is the type of scenario you'll be presented with, whereby you're given a PCAP file and you're told to analyze it and identify the infection and essentially what happened. All right, so we can use a filter here that's quite useful. We can say TLS handshake and the type of the handshake. So handshake dot type, we're going to say is equal to 1. So we're looking for successful handshakes. So you can see this is the protocol TLS version 1.2, and you can see that this is essentially going to be encrypted. So if we say follow TLS stream, in this case, is that nothing's being displayed. I'm just going to go back to my previous filter. Let me just select the handshake there. So TLS handshake equal 1, and TLS dot handshake type equal 1, and there we are. So I'm just going to filter those packets there, and you can see if I follow the TCP stream, all of that data is encrypted, right? Because there's an SSL certificate, right? Now, as I said, this exercise already provides you with the actual SSL keys to decrypt this traffic. So that's what is required in order to decrypt HTTPS or SSL traffic. So how do we decrypt this with the keys? Because we already have them, right? So in order to decrypt them, what we want to do is head over into Edit and into Preferences, and under Protocols, we're going to search for TLS. And right over here, you can see we have the pre-master secret log file name. So we can browse onto our desktop or where you saved the actual zip file. And you want to click on Wireshark tutorial keys log file and click on Open and hit OK. All right. And we can then get rid of that filter there. And if we take a look at the TLS handshake type equal 1, hit enter, and if we follow the actual TCP stream, you can see that it's still encrypted. But if we actually TLS, I'm just going to say TLS, there we are, TLS handshake type equal 1, And I'm just going to hit enter again there to filter it. And if we take a look at the actual TLS stream now, the traffic is, in this case, it looks like it's still encrypted. But yeah, I think it's actually decrypted at this point. There we are. So we can actually see the actual post requests here. So now our objective is to find out what, what system was infected and what malware essentially caused the infection. So what we're going to do now is we're going to use a filter. So we're going to say http.request, and we are also going to say or, and because we can use logical, the logical operators, and I'm just going to put this in a bracket, right? Because we're also going to be excluding a particular IP address or a particular protocol. So I'm going to say http request, and I'm going to say or tls.handshake.type, which is the filter we used previously, equal 1. And we're then going to say, and I want you to exclude a particular protocol. So SSDP, we want to exclude SSDP. So http.request, let me just make sure that is set correctly, http.request or, and we can then hit enter. So that tls.handshake .type equals 1, and I want to exclude SSDP. All right, so this is going to display all the actual HTTP requests or TLS handshakes, and it's going to exclude SSDP. And now from here, you can see all the actual HTTP requests, and there are different types of requests. We have a GET request, POST request. However, we can see a very interesting one here. We have a GET request, and that is, if we click on it, it's requesting for a particular resource, or it's downloading a resource. And in this case, the resource is a DLL. That's very interesting, right? And it's called invest20.ell. Now, to give you a bit of background as to what type of malware we're dealing with, in this particular case, a system on this network was essentially infected with the Dridex malware. All right, now the Dridex malware, you can actually research this on your own, is a type of malware that affects financial institutions, and it's typically the actual infection method is through particular Office documents, more specifically spreadsheets with custom macros. And what it does is it downloads specific tools or utilities that are used to then download the final piece of the malware. And in this case, it looks like we have a DLL here. All right, now what we can do once we've identified this DLL is, we can actually click on that there and follow the actual HTTP stream, right? So if we right click on it and say follow HTTP stream, we can actually see what happened. So we can see that this particular IP here, the source IP on the network, actually, performed a GET request to this particular server here, and you can see it's downloading, or it's making a GET request for this DLL, and then there's a response saying okay, it was able to find it, and then we have this octet stream or application data contained within that packet, and this looks to be the actual DLL because we get the we actually get the DOS stub here, which tells us that this program cannot be run in DOS mode. So that means this is the content of the DLL. Now, as a malware analyst or as a threat hunter, you would essentially need to essentially download the content of this DLL or save this DLL or the content within the DLL as a DLL file and then analyze it through a utility like, for example, like VirusTotal, for example, right? So how would we do this? Well, what we can do is we can actually export this as an object. Because we've already decrypted it, we can export this as an object. So what I'm going to do is I'm just going to click on that packet there, and I'm just going to get rid of that there. So if we use the previous filter, that's the one there, we can click on that particular packet and we can say file, export objects, and we want to export an HTTP object, and we're looking for this one here. So that's invest_20.dll, and we want to save this on our desktop as invest20.dll. So it actually saves the file that was downloaded. That's one of the cool things with Wireshark. and we can hit save. All right, so now that that is saved, we can utilize a service like VirusTotal to try and identify what type of malware this is. All right, so we can upload the actual malware there, and you can see this is marked as malware, and the original DLL is crowddry.dll, and you can essentially learn more about it here. So you can see that this is a Win32 DLL, portable executable, and you can also identify more information regarding when this particular piece of malware was created. All right, so you get information like that. You can also see what DLLs or Win APIs it imports. And of course, you can pretty much tell that this is quite malicious because it utilizes the Win32, or rather the actual kernel 32 DLL there, and a few others like WS32 DLL. So if you're familiar with malware analysis, then this is typically how you'd go about doing it. So you can see that the execution parents are through an Office OpenXML document. And these are the typical file names. So you have investments.doc. So you can click on that there. And yeah, so that's typically the infection method. So, you can click on the actual relations, and based on the number of relations, you have an idea as to the type of infection and what caused it. So in this case, it looks like this particular user on the network was essentially downloaded, the document. We're not really familiar or sure how they downloaded it. They probably got it through an email. They downloaded the Excel document and of course opened it up with Excel and executed the macro, which then which essentially executed code to download this particular DLL, which would then, infect the system. If we take a closer look at the actual packets within that particular filter that we had used previously, so let me just load it up here. You can also see that we have a couple of very interesting post requests being made to this particular server IP here. And the actual source port is as follows, which is quite unusual, and that is being made to this particular IP there, to a file called docs.php. That is very interesting. So it looks like after the connection or after the infection, it actually connects to the C2 server, right? That is operated by the attacker. So if we say follow the TLS stream, you can see, because we're able to decrypt it, that indeed this is the the command and control server. So this is going through man-in-the-middle proxy. And yeah, so it actually looks like that is the command and control server. So we've been able to decrypt the actual HTTPS traffic or the TLS traffic and identify the type of malware that caused the infection, as well as what system was infected. And of course, if we say, if we take a look at the system that was infected, so if we identify that there, let me just get rid of this filter here. And you can see that this system downloaded the DLL. So that's 10.4.1.101. And, we say nbns and we hit enter. You can see that the name of the actual host name is desktop U5 4AJ8K. So we now have a good idea as a threat analyst, as to what system was infected. And we can then, pass on this information to the relevant teams or the relevant individuals that can essentially handle, incident response and start analyzing the infected system and the scope of the infection. So that is how to utilize Wireshark to perform network traffic analysis. This video has been going on for quite a while, but I'll probably be making more videos on this. We will be taking a look at even more exercises, in regards to identifying malicious or unusual activity on a network, identifying the infected system, identifying what type of malware was used, or what systems it affected, the command and control server, so on and so forth. All right, so that concludes the practical demonstration side of this video, and this is where we're going to leave it. As I said, I will be making more videos on this. For now, we're now going to move on to our next video. So in the next video, we're going to be taking a look at how to essentially utilize Snort for intrusion detection. So I'll be seeing you in the next video.